polynomial function. This only works for polynomial. Second of all, real coefficients. All that real means is there's no i's. I don't have like an I times x. We'll deal with those ones later. If A does not equal B, all that means is if I have two different numbers, maybe 1, maybe 7. Those are two different numbers. If I have two different numbers and P of A and P of B, so these are the y values of those two different numbers. So maybe write this down to help yourself out. The A and B are x values. The P of A and P of B are y values. Okay? So if the two y values have opposite signs, what does it mean by opposite signs? One's positive, one's negative. Yeah, really separate. One's positive, one's negative. So if you have those two y values and one of them is positive, one of them is negative, then there is at least one real zero between A and B. So let me show you an example. What I'm going to do is I'm going to do an xy table really quick here. For this exact function that we just graphed. I'm going to do the x value of 0, and I'm going to do the x value of 2. This would be like my A and my B. Those are two different numbers, right? So I'm going to take 0, and I'm going to plug it into this function. I'm going to take 0, and I'm going to plug it into that function, and I'm going to end up with negative 6, because I already did that. And then I'm going to take 2, and I'm going to plug it into this function. So I'm going to actually do that. So negative 2 times negative 2 plus 1 all to the power of 3 times negative 2 plus 3. See how I just replaced all the x's with negative 2? And I got an answer of positive 2. Nice and boring. That's what I got.
Negative 2?
I plugged in negative 2 here. And I simplified, and I got an answer of positive 2.
Plugged in 2.
Oh, so why did he... Oh, sorry. Forgive me. I should have plugged in positive 2. You're right. I wanted the 2 value. Thank you. Hold on. Oh, dear. Hold on. There we go. Sorry. Thank you. I should have plugged in positive 2. If I plugged in positive 2, I ended up with the y value of 10. Thank you. Okay. So I plugged in these x values to get two different y values, right? Now, first of all, is this a polynomial function?
No.
Yes,
Oh,
it is.
yes.
I could multiply it all the way out if I wanted to. I'm not going to. This is a polynomial function. I picked an A and a B. They're different numbers, right? Do the y values have different signs? Yes. Right? So 0, negative 6 was right here. 2, 10 was somewhere up here. This was my 2, 10. This was my 0, negative 6, right? You see how they had opposite signs? What that meant is that I had to find a 0. There is a 0. Between this number and this number, it does cross the x-axis. There is an x-intercept. Does that make sense? Because one was negative, one was positive, I had to connect the dots somehow. And so I crossed the x-axis. There is an x-intercept. That real 0 is the same thing as saying an x-intercept. A real 0. That's what it means.
So, I'm sorry, one more time.
That's okay.
Since positive, one was positive, one was negative, they're opposite.
Yeah.
That means what?
That means there is an x-intercept somewhere in between those two x values that I have. A real 0 is the same thing as an x-intercept. Real 0, x-intercept, the same thing. Can you guys kind of see that picture a little bit? See a couple head nods. Let's take a break so you can soak that in, and then I'll do an example.
What about 0, negative 6? Okay, no, there's...
The y value is negative. The y value. Are you ready?
Ready.
We're ready as we're going to be, right? Okay, so here's the question. Use the intermediate value theorem to determine, if possible, if f of x has a 0 on the interval from a to b. So here's my function. F of x equals 1/3 x to the 4th minus x cubed. Here's my a, here's my b. So a is 1, b is 2. And the question is to use the intermediate value theorem, obviously. So I'm going to go back and I'm going to look at what the intermediate value theorem says. The first thing says is that it has to be a polynomial function. Do I have a polynomial function? Check. Good. Second thing, it says real coefficients. Yes, I have real coefficients. Does a and b not equal each other? Are they different numbers? Yes. What is my A and B? My A is 1, my B is 2. Easy enough, right? I'm just kind of following through. The next thing it says is P of A and P of B have opposite signs. So remember, those are the Y values. So the next thing I got to do is find the Y values to see if they have opposite signs. Okay? So we're going to find the Y values. So in this, that theorem called it P. I'm calling it F. It doesn't matter. You can call it whatever you want. So I'm going to plug in my A value, and I'm going to plug in my B value to see what I get. Yes?
Do the coefficients in the polynomial have anything to do with the theorem?
The coefficients have to be real, meaning I can't have an I as a coefficient. Does that make sense? Yes.
And what was your question? Do I have an A and a B that are not equal to each other?
Yes, and that came from A and B have to not be equal.
Okay.
So,
My A and B.
exactly, I had to make sure they're not the same number. If they're the same number, you can't do anything. It's useless. I'm not going to give you one where they're the same number. How about that? Because that's useless. Okay. All right, so now I got to find the Y value. So the Y values is what wasn't given to me. So I got to find the Y value. So I plug in 1. This is going to be 1/3 times 1 to the 4th minus 1 to the 3rd. You can do that math. I have faith in you. I know you probably use your calculator because I know how you are. But I'm going to tell you that answer is -2. You guys okay with that? Okay. Plug in 2. You guys can simplify that. 2 to the power 4 is what? 16. What's 2 to the power 3? 8. Just making sure. Yeah, at least one person awake, so that's good. And then 1/3 out here, and you could subtract, you could find a common denominator, or you could use a calculator. I'm just going to tell you the answer because I already know. So again, my two x values were different numbers. Then I took those two x values and I plugged them in to get two y values. And then the next thing is if they have opposite signs.
No.
Do they have opposite signs? No. So the answer isn't no. The answer is it's not possible. Not possible to determine by the intermediate value theorem. There might actually be a real zero, we don't know what it is. But the question is, the intermediate value theorem only works when they're opposite signs. So I'm going to say it's not possible to answer this question by the intermediate value. Yeah?
So can you also say that there's no solution?
No. Totally different things. Yeah.
So why are we doing this? Like, what's the point?
Good question. I like that question. Why are we doing this?
It's not possible to
This question
determine.
is not asking for the answer. It is asking if there is an answer.
And that answer would be x value, y
It
value.
says we don't know. We have no idea what the answer is. The question is there a zero?
So are we trying to find this?
No.
No.
We're just watching. It's a yes or no question. Is there a zero?
There is, but we can't figure it out by that theorem.
Right. Let me go back to that for a second. For example, in the real world, let's say you were engineering some device, and you wanted to figure out if there was some point that this device could fly at a certain speed. You don't necessarily need to know what that point is. You just need to know if it's possible. Because if it's possible, then you would continue engineering your device. If it's not possible, you're going to stop, right? So it's not about finding the answer, it's finding out if there is an answer. Does that make sense? For these ones, that's boring. Yes, no engineer is going to do that problem. I hear you. We got to start somewhere. Okay. Is that helpful? Let's do another one. One more example. Just like, same question, just I'm going to give you a different function. Okay. The same exact question, let's call this part B, and I'm going to give you, where's my function? I'll call this guy f of x equals x squared minus x minus 1, and I'm going to do the interval from -1 to 0. So again, the question is there an answer? I don't want to know what the answer is. I'm not asking you to solve. The question is there a real zero? Is there? I don't care what it is. So here's my A and here's my B. Is this a polynomial function? Yes. Are my A and B different numbers?
Yes.
Yes. So that was polynomial. Different numbers. The next thing is the y values need to have opposite signs. So let's find the y values. So I need to find, I'll do that in blue so it can match here. So I need to find f of -1, and I need to find f of 0, correct? good. I like this stuff. Nobody else seems to like it. I like it. It's good. It's fun. Trust me. Plug in -1. How do I plug in -1? So this is -1 squared minus -1 minus 1, right? Take your time to simplify that out.
They're both -1.
Take your time. Let's see how we can agree. Remember, it's easier when I do it for you, so I'm going to challenge you. You do it for me.
It's -1.
First one.
One.
One and negative.
This one was 1.
Yeah.
What's -1 squared?
Positive 1.
One.
2
Oh.
negatives give me a positive, so this becomes 1 plus 1, which is 2. Minus 1, which is positive 1. And then this gave me 0 squared minus 0 minus 1, which gave me a -1.
So it is possible.
So it is possible, right? So because I have opposite signs, I can now finish the rest of the theorem. Then, because it's an if-then statement. If this happens, then this happens. Welcome to science. You guys remember that if-then statements in like biology class a long time ago? Okay. Then, there is at least one real zero between A and B. So, by the intermediate value theorem, there is an answer. There is at least one real zero between -1 and 0. So maybe that answer is -0.5. I don't know what the answer is. All I know is that there is an answer. There is a 0 somewhere between -1 and 0. So it does exist. It crosses the x-axis somewhere. Awesome. I did not ask you to solve, so don't start doing the quadratic formula. I didn't ask you to solve. Yeah.
Do we have to answer it in a sentence like that?
Yes. Remember also in that biology class a long time ago when you had to write up like a lab report after you did your experiment? And my guess is you had to write some type of sentence? Yes. You can't just write the word yes. It doesn't mean anything. You have to explain yourself.
So we can't just put yes, it is possible?
No, you have to explain that the intermediate value theorem tells me not only is it possible, but there is a real zero.
The IVT is used to find if a polynomial equation function has a zero.
Yes. It is not used to determine what the zero is.
Just if it has one.
Right. This is good. Ta-da! Questions on that? Yes, sir.
Does the sentence have to be that long, or do you
Here's what I'm going to do then. I'm going to say yes. The sentence has to be that long. And just for you, I'm going to make you write out intermediate.
But you're teaching us to be math majors.
I know, that's why I made this an IVT, and that's why that's a lowercase b. This isn't even a sentence. Meet me halfway, all right? That's like, you can write IVT, that's the shortest you can do. You can write the ampersand if you want instead of the A and B.
That's
Helping you out here, you're welcome. All right, questions on that? Okay, so let's do another one.